In this video, we will be looking at different forms that quadratic relations can be represented in, so different types of equations. So we're going to start with a little investigation. The parabola on the right can be represented by both of these equations. So we have y equals x plus 3 and x plus 5, and this is called your factored form, which is familiar to us for when we factor a simple trinomial. And the standard form is y equals x squared plus 8x plus 15. So just a reminder, if we want to go from factored form into the standard form, we would always do our FOIL. If we want to go from the standard form to the factored form, in this case, we would factor using the simple trinomial. Now both of these equations represent this parabola on the right here, and we're going to identify some properties. So this particular parabola does open up, because if I were to put arrows at the ends, they go upwards. The y-intercept, if I look at my y-axis, we're passing through 15, so 0, 15. And our zeros, or our x-intercepts, are right here on the x-axis, so that's negative 5, 0, and negative 3, 0. Now you might be looking at these numbers and maybe you see that some numbers are matching. For example, our y-intercept of 15 is matching the constant in standard form, that last number. And if we look at our 0, the negative 5 and negative 3 look quite familiar in that in our brackets we have plus 3 and plus 5, and then our zeros are minus 3 and minus 5. So it looks like they're the same numbers, just opposite signs. That's one observation we could be making. Let's see if it applies to our second parabola. So in the second one, we have the factored form as y equals negative 2, x plus 1, x minus 4, and then the standard is negative 2x squared plus 6x plus 8. So in terms of the opening, if I were to put arrows, they're going downwards. So our parabola opens down. The y-intercept is 8. And our zeros, we have one at negative 1 and the other at positive 4. So let's make some observations again. Let's start with the y-intercept. We saw it visually to be 8. And it actually matches the constant, just like in the other scenario. For our zeros, we have negative 1, and one of our brackets is positive 1. So there's that opposite sign, and the other one was positive 4, and our bracket said negative 4. So we did perfectly flip our signs, just like in the previous investigation. Now, in terms of the direction of opening, one of them opened up, one of them opened down. And the special feature here, which we have seen before, is the fact that the coefficient of x squared in the second one was negative, which made it open down, and in the first one it was positive, which made it open up. So I'm just going to highlight that as well. So the up came from the positive 1 here, and the down came from the negative 2. Now, let's summarize that. Looking at part 1 and 2, make some observations. So how do you get factored form? You factor, so it could be a greatest common factor, it could be a simple trinomial, or a difference of squares. How do you get your standard form? FOIL, or just distribution. Which form does the y-intercept come from and how? So it came from that standard form, and it was the constant at the end. Where do the zeros come from? We saw that they came from the factored form, and they were opposite signs. So same numbers, opposite. Finally, how can you identify the direction of opening? So it came from the coefficient of x squared. If it was positive, it opened up. If it was negative, it opened down. All right. Let's make some predictions. So parabola 1 is y equals x minus 2x plus 6, and then y equals x squared plus 4x minus 12. For our y-intercept, our prediction would be, well, it's probably related to the constant. The constant is negative 12. So 0, comma, negative 12. The zeros come from the factored form, but we take the opposite sign. So if it says minus 2, it's going to be positive 2, comma 0. If it says plus 6, it's going to be negative 6, comma 0. And in terms of the direction of opening, I'm going to look right here in front of x squared, or I can look here in front of my brackets. And there's nothing there, which just means it's a positive 1. So it opens up. Now I don't have Desmos open for me, so I will just tell you that these are all correct. So for parabola 2, we have y equals negative x plus 1, x plus 5, and y equals negative x squared minus 6x minus 5. So I want you to pause the video here, make your prediction. You can use parabola 1 as a guide, and then come back to check your work. So the y-intercept should have been negative 5. Now that there is potential for a mistake here, if you just said positive 5, the sign belongs to it. For our zeros, we have plus 1 and plus 5 in our brackets, so our zeros should be negative 1 and negative 5. Now these rules are things that you just have to remember based off the observations we made in our little investigation. And finally, there is a negative in front of both the factored and standard form, so that means our parabola opens down. Okay, parabola 3. We have y equals negative 2, x minus 4, x plus 3, and y equals negative 2x squared plus 2x plus 24. So they're the same parabola, and in this scenario, well, in these little scenarios here, I'm giving you both forms. We will move on to when I give you one form and you have to manipulate it to get the other form by doing distribution or factoring. But for now, we're just trying to get those observations intact. Okay, so again, pause the video, identify the properties, then come back to check your work. So our y-intercept should be the constant in standard form, so 0, 24. The zeros, we look inside our brackets, we have negative 4, which means the 0 is positive 4, 0. And then we have plus 3, which means the 0 is negative 3, 0. A common mistake here is that people forget to switch the sign, but that is what we observed. And finally, for the direction of opening, we do have that negative in front of the 2. The 2 doesn't mean anything to me, but the negative does. So we're opening down. And the last one is a little bit challenging because something might be missing. So in terms of the y-intercept, I would be looking at my standard form, but there's no constant. Okay, you can't tell me that the y-intercept is negative 6 because the negative 6 is attached to an x. But remember, when something's missing, it's technically just a 0. So the y-intercept is just 0. In terms of the zeros, I have no problem with this bracket. It says x minus 2, so that means positive 2 for a 0. But this other bracket has nothing in it. So once again, technically I can write it as x plus 0 or x minus 0, whatever you want to say. So just 0. When something's missing, the property is 0. And then for the direction of opening, we have a positive 3 here. It's positive, so that means up. And there we have it. All right. Now we're going to move on. We're going to determine all of those properties first from factored form, then from standard form. So we're going to kind of bring everything together from this unit because we're also going to practice our distribution and we're also going to practice our factoring. So from factoring, or from factored form, we know the zeros come from here. And we also know that we can get the direction of opening. So I'm going to start with those ones. The y-intercept, I can't get it just yet. So the number here in front of the bracket is positive. So that means it opens up. I also added another property here about if there is a maximum or a minimum, which relates to the vertex. Now, we can't get the vertex from here super quick, so all I want to know is if there's a maximum or a minimum. And that just comes from the direction of opening. Because this opens up, my vertex here is a minimum. So there we are, 2 properties done. Now, the zeros we know come from inside the brackets. So the zeros are, instead of -4, +4. Instead of +6, -6. And there it is. Now the y-intercept, well, I need this to be in standard form and not a problem. We know how to get to standard form. It's just FOIL or distribution. So expand for standard form. So I'm just going to rewrite the equation. X minus 4, x plus 6. And we know that to expand this, we're going to multiply the x into our second bracket. So x times x is x squared. X times +6 is 6x. Then I'm going to multiply the -4 into that second bracket. So -4 times x and -4 times 6. And we always collected our like terms in the middle. So 6 minus 4 is 2. And now, here's the constant. So our y-intercept is 0, -24. So another little mistake here, make sure, for the zeros we switch our signs, but for the y-intercept we do not. It is whatever the constant is. And there we are. Let's try another factored form. This time all I did was I added a little coefficient in front of the bracket. It really doesn't do anything except when we FOIL, it's going to add a little bit more work for us. So this 2 is positive. So that means it opens up. And once again, because it's opening up, I like to personally draw this sketch for myself. That way I can clearly see that we have a minimum. It's a more visual way. Instead of memorizing up means min, down means max. The visual doesn't make you memorize anything. My zeros, both the numbers in the brackets are positive. So that means our zeros are both going to be negative. So instead of +1, -1. Instead of +7, -7. Okay. And now finally, let's do some expanding. Now because we do have that coefficient out in front, that means we're going to keep the 2 out, open up a bracket, and now we can do our FOIL. Make sure when you do have like 3 components to multiply, do the FOIL first. So we'll do x times x to get the typical x squared, x times 7 to get 7x. Then we're multiplying the 1 in. 1 times x, 1 times 7. I like to collect my like terms first, and then I'll deal with the 2. So be careful here. Because we still have the 2 out in front, the 7 is not your y-intercept. So x squared, and then 7 plus 1 is 8 x's. And now we can do a quick distribution of the 2. 2 times x squared, 2 times 8 x, and 2 times 7 is 14. And there it is. The 14 is our y-intercept. So 0, 14. So if I give you factored form, you have every property in front of you except the y-intercept. And that's just going to require you to do that additional distribution or FOIL. Let's go in the other direction. Here's your standard form, and let's get those properties. So direction of opening is always a safe one to start with. The value in front of x squared is positive. So this opens up, which again we have a minimum. We can get the y-intercept super quickly here, just the -10. So 0, -10. And in terms of the zeros, we need to factor. So for zeros, factor. And now we do have to pick, is it GCF, greatest common factor? Is it a simple trinomial? Or is it a difference of squares? So first of all, it's 3 terms, and the value in front of x squared is 1. So in this scenario, it is going to be a simple trinomial. So if we're doing a simple trinomial, remember, we need a product or multiplication to the -10, the constant, and we need a sum or addition to the -3. So if my product is negative, I know I need one positive and one negative number. So that might be -5 and 2. And that would be perfect because -5 plus 2 is -3. And now that we have the magic numbers, we just put them in our brackets. Make sure when you put them in the brackets, you keep the signs as is. We're only going to switch them around when we talk about the zeros. So instead of -5, we're going to have +5. Instead of +2, we're going to have -2. And there we have it. All right, let's try one more. So I just want you to pause the video here. Tell me if it opens up or down, if it's a max or min, and tell me the y-intercept. Then we'll do the factoring together. Unless you're confident with the factoring, then go for it. All right, once again, the coefficient of x squared is +1. So it opens up like the rest, but I promise there are scenarios where they open down. And that means we have a minimum. Our y-intercept is just the -36. So 0, -36. Notice I'm always writing these special properties as coordinates because that's proper communication. And in terms of factoring, I only have 2 terms here, so I know it's not going to be a simple trinomial. Is there a greatest common factor? I don't see one. Is it a difference of squares? Well, it's 2 terms. It's subtraction, so it's a difference. And both terms are square rootable. So we do have a difference of squares here. So remember, with a difference of squares, we square root both of our terms. So the square root of x squared is just x, and the square root of 36 is 6. And this is the nice quick one to factor. We just set up 2 brackets. The square root of x squared was x. The square root of 36 was 6. One bracket will be positive, one bracket will be negative. And there it is. So our zeros, for the first bracket, that was x plus 6. We're going to write -6. For the second bracket, that was -6. We'd write +6. So here, honestly, if you messed up with the signs, you would be okay because you end up having both the positive and the negative version of 6. So that's it for our special properties. So your standard form gives you your y-intercept, and you can always get it by expanding. Your factored form gives you your zeros, opposite signs, and it can always be found by factoring. Your opening comes from the coefficient of x squared, so that number at the very start, you can get it from anywhere. And same with if it's a maximum or a minimum, a quick little visual will give you that information. And that's it.